I'm going to talk to you a little bit about some business opportunities that I see around Ricoh Theta or 360 cameras in general. I'm seeing a rise of visual documentation, and this is where a lot of the business opportunities are taking place. And so I'll explain to you what exactly is this. Thanks for coming here. You probably have read a bunch of headlines, and thus you're here, about big deployments of AR and VR. Last month, Walmart is announced that they're going to deploy 17,000 of these headsets. That's a huge number, 17,000. To train the employees in VR, right? So we may imagine the 17,000 headsets and then ignore the second part of the sentence, which is training the employees in VR. What does this mean? The actual deployment's being done by a company called Striver. The CEO, they're in Menlo Park, was the assistant coach at Stanford for football, gave that up following the startup path. He's an entrepreneur, like everyone in this room, like I am, and he's making a go of it for VR. So if you analyze the deal, he talks a lot about documenting the processes, the operations process procedures for the Walmart employees to train other employees more efficiently. The actual type of training they're doing deals with produce, other areas of the store. It started off with produce. There's equipment, there's space, right? So you take a picture, it's a picture or a video, not a 3D model, and you look at how the correct way to maybe change the lettuce, change out the meats, set the temperature on the equipment, verify the quality control of the produce in the store. Once you have the correct process, you then send it out to the 17,000 headsets around. And then the individual employees can then view the correct process in a VR headset. The reason that it's in VR is you probably want to see what's going on around the employee, right? Because there's aisles in the store, there may be boxes, you may have dollies, you may have to wheel things back and forth. So you actually want to see what is in back of the employee that you're on. With a normal camera, you can't do this. This is one of the advantages of VR. Okay, let's look at maybe try to figure out what some other opportunities might be. Well, you're probably reading the headlines, right? So if you just read the news, it's pretty hard to miss any. Every week that goes by, there seems to be another AR, VR investment, right? And so you're seeing money is flowing in, more money is flowing in. You're like, okay, what's going on here? This company, actually, we know this person. He's doing telepresence in space. Okay, well, I'm not going to put anything in space. So, okay, where's the actual money flowing into? Well, if you look at 2017, there were a lot of deals, and there was $3 billion invested in AR, VR. So the size of the investment is pretty big for a nascent stage of the type of industry that AR and VR is in right now. So let's do an analysis of where the $3 billion went. So if you look at what type of industries are receiving investment for AR, VR, there is no common trend. You might see some enterprise or social. What does enterprise really mean, right? I mean, it's Walmart. That's probably an enterprise deal, but it's not really clear. You can't. It's across a wide breadth of industries. So we know the money's there. Analysis is not really helping us to identify the specific opportunity. So let's take a step back. Okay, we're here. We see the money is flowing in. We're seeing the headsets. We're seeing the high-tech cameras, and we're pretty excited. So we could be developers, photographers. We could be users. We're all welcome, and we're all part of this VR industry. My suggestion is for us to think of it as a frontier. Ignore the fact that these headsets and cameras are actually quite high tech. Imagine that it's just the beginning. The cameras are going to evolve. The headsets will evolve. It's a very nascent stage. So instead of thinking that the camera is the end goal, you have to think of it that what is the camera going to be in 2 years? What is the headset going to be in 2 years? It's going to be very different than what it is right now. Every year that passes, every 2 years that passes, the cameras are evolving very rapidly. There are no experts. You have not missed the boat in any way. It's almost like we're going across the West and discovering new places. In fact, the people in this room are the ones that are actually creating the stories. We're defining the markets. We're not following the markets, we're defining it. And we're creating the technology. It's all happening right now, perhaps with a team of people bringing different skill sets. Maybe the people in this room you can meet. You can meet with developers, photographers, users, find out and collaborate and build something new. The opportunities are everywhere. So trying to hone down on what these opportunities are, right? We're probably fascinated by the experience of AR and VR. This TV-like or film industry fantasy thing where we go in there and we're transported into a new world. And although this is a real opportunity as well too, my ask to you is to think a little bit differently today. Think of a 360 image or video as a piece of data or a documentation. And this mindset may actually lead you for a better business opportunity. Let's look at some business examples. So the column on the left, tourism, training, real estate, used car sales, VR telepresence. I'm going to categorize this all as a type of experience. And we can understand what these are. There's another type of business example. These are real examples of companies that we work with. Construction documentation, visual special effects light. What does this mean? Forensic science. Well, how is the 360 image used? Retail store traffic analysis, radiation measurement. This is all using the images as a form of visual documentation, and that's what I'm going to explain. I think we can understand already, even before coming to this room, what is going on the left-hand side. On the right-hand side, this is just a taste of some of the thousands of potential business opportunities that are out there. Let's look at forensic science. Let's first understand what the product is. On the right-hand side, you have a tablet, you have a camera, and a tripod. It's a Ricoh Theta. They sell the full package, along with a nice duffel bag. The left-hand side, they have some software that's used to upload the 360 images that you take at a crime scene, you organize it, you put it on a map. This company, in order to produce an OSCR 360, they have very close ties with a specific industry, which is law enforcement. You can see the happy, great police officers surrounded, they're all crowded around the Ricoh Theta, the star of the picture, in my opinion. You have to have very specific knowledge of an industry. This knowledge of the industry is more important actually than graphics knowledge for this type of application. You also have to understand the workflow. What actually happens when you take the picture and to the point where you're actually using the picture to meet your business goal. So you first take the picture at the crime scene, right? So the crime scene is kind of chaotic. It's highly regulated. You have to take the pictures in a certain way. Once you have the pictures, you upload it to some type of software system, right? This is the contain section here. These are evidence files, right, that you're uploading into the software. You then organize and set up the relationships of your evidence. You're preparing actually to go into court. Remember, this is it's a legal evidence document that you're creating. You present it to the jury, the judge, and the scene, and you find the truth. So this is just one of the many workflows that if you have knowledge of, you can leverage AR, VR, regardless of whether you're a photographer, a developer, or just a user. You might see a business opportunity if you know a specific industry very well. A couple more examples of different types of industries. This one's a little bit niche, but maybe you have specific knowledge of nuclear power industry or some type of power industry. In this example, they're using a Theta to take a picture. That's the front one. They're using another sensor to record the radiation. They overlay the radiation on top of the image taken by the Theta, and they create a composite image that shows you where the radiation is leaking from. The sensor and the theta, they're on the end of a robotic arm, so no humans were injured in the taking of this picture. Another industry, very popular, where the theta is very popular in, is the visual special effects. So the visual special effects industry, they bring the theta on set. The theta is not the star of the show. The theta is not taking the images or the video that's used in these movies for Hollywood. What the theta is used for is to capture light and color information. It's actually capturing data. That data is then used back in the artist's studio when they create the 3D model to calculate the reflection. You see this reflection here, here, and on this photorealistic. You create the model in some type of software. You need to light the model. The light of a scene changes. I think you can understand that if you rotate the model, you want it to, the reflections to change corresponding to the light of the scene. The type of light and color data that is captured, here's an example. So you take 12 images. Each of the images has a different exposure setting from light to dark. You capture all 12 settings. You put that into a single file. It's called an HDRI file. And you then use that file to light your scene and calculate the reflections. So this, if you want to play around with it, you can just do it yourself. This is free software. It's called a Luminance HDR. Another example of a workflow is construction. So in construction, they're using time to go back and forth in time. You take a bunch of pictures and you apply it onto a floor plan, and then you take it at regular intervals of time. 6 months passes, you can then see whether the construction was going according to schedule, whether it's in compliance, whether it was, let's say that a wall was built over a pipe. You can see what happened at different stages. This also requires specific knowledge of a workflow. In fact, this company, Holobitter, had to hire a bunch of civil engineers in order to really make some inroads into this space. And now they're doing great. Let's talk about data collection. How is the theta used for data collection? Well, the basic method is you put it on a tripod and you bring it into a room. You just take the picture, either self-timer or a mobile app. In most cases, it's using some type of mobile app, custom mobile app you can make. Other companies, they're making the theta a little bit more mobile because this is manual. So if you put it on a drone, and this particular drone can actually know when its battery is low, and it will self-dock and it'll charge wirelessly and then go out and collect more data. The data is then transmitted over to another server, and you can then analyze it that way. So what type of data, right? So you can look at light, color, date, time, camera orientation, compass, GPS coordinates. So on the right-hand side, I'm using a tool called XF2 GUI, and then you can go through the XF data. So if you don't know, the actual image has a bunch of data that's attached to it as metadata, and you can write that data to the image and you can read it. So when you're writing your program or if you're creating something, there is some level of data that you can be stored directly as far as in the XF image. So other types of data, you can use the image itself and basically calculate the data for yourself. So in this example, the camera itself can know whether there's a person in the picture. So you can classify objects within the camera itself and then store that as data too, so you can get access to it. So how much data are we talking about? It's a pretty staggering level of data. So there's a Google Street View app. I'm a Google Street View trusted photographer. And if I'm using this app, which only is taking at 5 frames per second, 5.4K video. But if you take 24 hours of video, this will be 792 gigabytes. So we're talking about really large volumes of data, if you're going to use cloud processing and the person is, your application involves using video as a source, and then you hoping to process it in the cloud, you have to take into consideration that you might be dealing with 10 terabytes of data, right? I mean, you have to have a fairly big pipe and to actually get it over to the place to process it. You may want to process it in the camera. So this type of, what they're using the video for, right? So they're taking Google Street View. This is Google Maps. Instead of taking individual pictures, you set the camera into video mode, and you go around in a car, bicycle, or you walk around the entire perimeter of the island. And you'll take hundreds and hundreds of spheres, images automatically. You upload the video file itself to Google. And this is why I'm saying that it's a lot of data, because when I upload it, it actually takes me a long period of time because I have a slow internet bandwidth. If you have faster bandwidth, it'll be faster for you, but it's still a lot of data. And then Google actually then processes the images, the video, and processes it into images in the cloud. So what actually appears on the maps are actually still images in a Street View format where you can rotate it. What's uploaded is actually the video file. So although I spoke a lot about using visual documentation, obviously the experience aspect of AR, VR is absolutely red hot. And the Ricoh Theta is right in the center of it. So although I did say it was possibly more lucrative, at least in the short term, to use the images and the video as a form of documentation data, this experience aspect of AR, VR is very hot. On the left-hand side, this person actually has a telepresence system for space. It's haptic feedback. The video and the sensor data from the robot is transmitted from space. It goes back to the user. And then when the user moves, in this case, the robotic arm moves. On the right-hand side, this is stereoscopic 3D vision using two Theta cameras that are synced together, and the cameras actually move. It's on a Segway, and the chair itself rotates. There's other types of haptic feedback for the user in the right-hand picture.